Please finish up your conversations. Eyes on slides. Now, I think there's one person missing, and I want to put this in for posterity anyway, because I might think of a question based on this. Oh, I want to wait for him to come back because he needs to. There we go. All right, I wanted you to come back, McKinley. So take a look at the chat box. There's going to be a lot here. There's going to be a lot here. So scroll up a little bit. You guys saw it already, but I want to take another look at it myself. So there's a question about one-to-one relations and how 2x squared plus 4 can't have an inverse. Otherwise, the inverse won't be a function. Because there's something else next to that 2x squared plus 4 for a reason. So why don't we get into that now? So what does it say? Why don't you guys put in the chat box, what does it say next to the 2x squared plus 4 here? What's it say next to the 2x squared plus 4? That there is a domain restriction. Yes, specifically, what is it for this one? What's the domain restriction? Domain x is greater than or equal to 0. All right, so let's start at the top, shall we? The notes here. I didn't mean to foster this because pre-AP students are very bad at reading directions. They jump right to it, which can be great sometimes. Let's first a couple things. Do you remember yesterday when we did the inverse of the Celsius as a function of Fahrenheit, and then we did Fahrenheit as a function of Celsius? Remember when we did that yesterday? So how did we do that? We didn't switch the x and y. We kept C and F where they were, and we solved. So in an application problem such as, Fahrenheit to Celsius, Celsius to Fahrenheit, or something like that, in an application problem, you just solve the equation for the independent variable. So in an application problem, you don't switch the variables, you just get F by itself, which is what we did here. Okay, and if I gave you this, you would have gotten C by itself, and you would have gotten that. So in an application problem, real world, like Fahrenheit to Celsius, Celsius to Fahrenheit, you just solve the equation for the independent variable. Now, in a non-application problem, which is mostly what you're going to be doing, I want you to asterisk this. You need to switch the x and y and solve for y, and that was the direction that was on the do now. And then there's this last bullet here that I started with because McKinley asked a very good question about domain restrictions, because you need to ensure that the inverse will be a function. So there's a reason why I didn't want you guys to write anything here. I'll tell you when to copy down stuff. There's not much to. So if you have y equals x squared, you guys have seen this parabola many, many times. All right, you have y equals x squared there. So you guys can draw that. And when you have y equals x squared, you've got your inverse that you have to reflect over y equals x. So the y equals x line kind of goes like that. I'm just drawing it here. And you sketch over y equals x to graph the inverse of this parabola. What you're going to graph is going to be on its side like this. So after I do this, why don't you guys draw just that? Okay, if you reflected that entire parabola on the left over y equals x, it would look like that. Might be helpful to have both of them on there. Okay, so here's the thing, though. What is wrong with this? It actually asked this question here. What's wrong with this sideways parabola? What's wrong with this sideways parabola? It's what McKinley brought up earlier. Correct. It's not a function. It's not a function. So we need to think about domain restrictions to ensure that the original sketch is a function and that its inverse will be a function. So let's do that here. Let's do that here. What would I have to restrict the domain of y equals x squared to be so that I'd have an inverse function? Think about the function that x squared will be when you inverse it. Okay, kind of think about what you did here with these two. Yeah, very good. If you have x is greater than or equal to 0, okay, so write that down. X is greater than or equal to 0. That would be your domain restriction. Okay, so that's your domain restriction. What about your range restriction? Would that affect the range as well? If you restrict the domain, what's the range restriction going to be? What's the range restriction going to be? By the way, it's going to be the same anyway. Yeah, y is going to be, it'd be the same as in the regular parabola, just in this instance, maybe in other instances too. You're going to have y is greater than or equal to 0. Okay, so write both of those down. I'm going to highlight in black. If you want to do it in a different color, you're welcome to, or you can just rewatch this lesson. I'm going to highlight in black. You can maybe just darken it. If I were to restrict the domain and then therefore the range, which is the same either way, if I'm restricting the domain, I'm only inputting 0 and then all the other x's above 0 all the way to infinity. So I'm going to darken this parabola like so, to show you the restricted domain function that we have of y equals x squared with a restricted domain of x greater than or equal to 0. It's going to be just that. So I want you to copy that. And if you restricted this domain in this range, and you were to just take this graph and reflect it over y equals x, if you were to reflect it over that line, y equals x right here, it would look like the top half or bottom half here. The top half or bottom half. Yeah, it'd look like the top half here. So I'm going to darken this guy right here. I'm going to darken that guy. So what's the domain and range restriction on this inverse? What's the domain and range restriction on this inverse? We're just looking at the graph. What's the domain and range restriction on this inverse? It's only in the first quadrant. Yep, so let's do them separately. We have a domain restriction of x is greater than or equal to 0. And we have a range restriction of y is greater than or equal to 0. There's two other notes after this question. The question I have is, no, not the question, sorry. The statement I have is, you don't realize it yet, but you actually switched the domain and range with the inverse. You'll see this with these. You actually switched the domain and range. It's just because they were named, they didn't look it. But they will look it very soon, by the end of this class. So what function is pictured here? What function is pictured here? What function's pictured here? Put it in the chat box. Well, what is the inverse? Yeah. What is the inverse of x squared? It's going to be, let's write our equation, y equals the square root of x. Now, you don't have to do this, but you may want to, I stole this from Sal Khan at Khan Academy. I do like that little tail there because there's going to be a lot of stuff going on underneath and sometimes not when we get to radical functions. If you don't have to do this, but I like to do it to show what's being square rooted, just that x alone. Because soon we're going to have the square root of x, plus 5 or something like that. Or you're going to have the square root of 2x plus 5. Is the plus 5 underneath the square root, or is it outside the square root? Good. So the reason why we have these domain restrictions is because unless we wanted a non-function, which we don't, I want you to write this. We must restrict the domain of we must restrict the domain of, this is very important, y equals x squared. We're restricting the domain of the original function so that the inverse will still be a function. Okay, make sure you've got y equals x squared. Now let's get to number one here that you guys did for the do now. Let's take a look. So I told you guys in the do now to just make this y equals 2x squared plus 4. I know you guys are going to be jumping into this stuff soon enough. And then to switch, actually, I don't want to switch just yet. I want to first draw this function. I want to draw this function with this domain restriction. So I'm going to just sketch this out. And 2x squared plus 4, we have a vertical stretch of 2. We have the x squared function of 4. But we have a domain restriction where it's just going to be to the right. It's going to be, we're going to have 0 and then every number above 0. So I'm going to just put a dotted here just to show that if you were going to graph this function without a domain restriction, it would look like a parabola, raised up 4, vertical stretch of 2. However, there's a domain restriction, which I want to put in, marking this here. There's a domain restriction on this kind of right side of the parabola. And it is going to reflect over our favorite line here with inverses, which is y equals x. So it's going to reflect, and we're going to be here with our reflection. So I've done everything graphically so far. Now we need to find what the equation is going to be for this. And what kind of equation? I'm not asking for the answer just yet. What kind of equation are we going to have? We have a quadratic up here. What kind of equation is going to be the inverse? Good. It's going to be a square root. So let's see how we get that. Now let's go to the algebra. Constantly switching colors here. Because x equals 2y squared plus 4. I told you guys to do that. Switch the x and the y. And then you use your algebra. You subtract 4. Then you divide by 2. Then you square root. And what you're going to come out to is you're going to come out to y equals, because you're getting the y by itself, y equals the square root of, what did you guys have? Put it in the chat box. It's going to take you a second to write all of it. U1409 sounds perfect. Yeah, we're going to have the square root of x minus 4 all over 2. And that's why I like that little hook at the end, so you're square rooting that entire thing. And let's talk about notation now. This means, if you remember from geometry, where we did like inverse sine, inverse tangent, inverse cosine, this means inverse of function x, or function of x inverse. This is not f to the minus 1 power. Okay, this is not f to the negative 1 power as an exponent. This is the inverse of your original function of x up here. The inverse of the original function of x is going to equal the square root, big square root here, the square root of x minus 4 all over 2. So the domain restriction now. What's the domain restriction of this function here? What's the domain restriction? So we're looking at this part of the graph. What's the domain restriction of this guy here? What's going to be the domain restriction of this graph here? So here's our inverse function. What's our domain restriction going to be? Here's where I want a lot of the thinking to take place today with this. All right, Rhea is asking the class, what do you think of her conjecture that x is greater than or equal to 4? What do you guys think of that? Anybody else? Anybody else? Is the domain restriction x greater than or equal to 4? Is the domain restriction x greater than or equal to 4? Everybody in? Two more? Is the restriction x greater than or equal to 4? Very good. Yes, it indeed is. It indeed is. Now, let's talk about why. There's two reasons why. Does anybody want to put a reason why x is greater than or equal to 4? There's two different answers here. Oh, there's three different answers. Okay. Okay. Yes. Yeah, there's three different answers. I didn't even think of that, McKinley. Thank you. Yes. Yes, that was what I was looking for. That's what I was looking for. Why not? Why not? Yeah, we're talking about problem one. Yeah, no, it's not related to, don't get confused. I'm not talking about this. This just happens to have a domain restriction on the original. We're talking about the inverse right here. Yeah, so let me write this here. Let me write this here. Let's do all this. Let's start with McKinley's point. The range restriction, the original range restriction was, sorry, the range restriction ended up being 4 is greater than, or sorry, y is greater than or equal to 0. Another thing I want to say, what point is this? This point, sorry, greater than or equal to 4. Greater than or equal to 4. All right, y is greater than or equal to 4. This point right here is 0, 4. What's this point right here? What's this point right here on the inverse? Remember when I talked about switching domain and range? Look at what we did algebraically. We switched x and y. What's this point right here? With parentheses, please. Yeah, this point here is 4, 0. This point's 4, 0. So the three answers I was looking for two initially. The first, McKinley's answer, that the original range restriction will become the domain restriction. Okay, the original range restriction will become, the original range and domain restrictions will switch. So you can even say that y is going to be greater than or equal to 0 as a range restriction here. That's range, that's domain. Okay, so the new inverse, the domain restriction is going to be x greater than or equal to 4. Range is going to be y greater than or equal to 0 because these are going to switch. The second thing I was looking for was graphically it starts at 4, 0. So the lowest number you can put is 4. But why algebraically is that true? And Lavick had it that if you have anything less than 4 here, if you do 3, what happens if you put 3 in for x? What are you going to have underneath the square root? There isn't really an inverse of a linear function, right? Yeah. It'd be no, sorry. It would be another linear function. Yes. I was thinking of y equals x. Like you can't inverse y equals x to make x equals y. What you got, Roshan? Yes. Yes. It'd be more than that though. Let's make it easier for you. What if you put 0 in for x? Not 0. You want 8 minus 4, negative 8 minus 4? Yeah. What if you put negative 4 in for x? If you had negative 4 minus 4 divided by 2, you'd have 2i or 4i. Yeah. So what's the problem with that? What's the problem with that? We're on a what kind of plane here? We're on a Cartesian coordinate plane. So you can't have that. We're restricting the domain to the real numbers. We're restricting the domain to the real numbers. Good. So with that knowledge, I want you guys to finish number 2 and raise your hand when you're done. Make sure you have a domain and range restrictions there. Okay, you need to redraw this, but have everything else that's here. Have everything else that's here. Finish number 2 with domain and range restrictions and raise your hand. Yeah, I was just trying to point out that you can't have the imaginary numbers. I was trying to do some silly stuff in my head with you guys. Yeah. Yeah, don't worry about that. We're staying in the real world with the real numbers. Yep. So raise your hand when you're done with number 2 with the domain and range restrictions. I know you guys started the problem. Those with their hands raised, you can do number 3 and 4. I want you guys to take a second to turn and talk. And I'll leave you guys with the answer key in a second. Turn and talk. Last thing here. What kind of function, when you see a quadratic and they're looking for the inverse, what kind of function are you going to end up with as an answer? What kind of function are you going to end up with as an answer? What kind of function did you guys end up with as an answer? Yes, a square root. Good. So take a look at the answer key. that was so nicely provided for you. Take a look here. This is the original restricted domain function. And then here's the square root that's reflected over y equals x. Take a look at all of the math here. All right, take a look at the domain restriction here. If you have anything below -2, if you had like -3 here, -3 plus 2 is a -1/3. You can't do the square root of -1/3. It's undefined. Okay, make sure you've got the inverse function notation. Check all the math. Finish up 3 and 4, and I'll see you guys tomorrow.